California has a fake volcano, and it just lit a plastic pipe on fire for the second time in less than 2 years. Locals call it the Hope Ranch Volcano. It's a stretch of coastal cliff about a mile west of Arroyo Burro Beach in Santa Barbara County that has been smoking on and off since at least 1795. Every couple of years, smoke rises from the bluff. Fire crews respond. The smoke clears. The thing is, it isn't a volcano. The last volcanic activity on this coast ended about 30 million years ago. What's happening inside that cliff is chemistry. Iron sulfide minerals reacting with oxygen, generating heat that ignites offshore tar trapped in the same rock layers. But here's the part that doesn't show up in the local headlines. The thing that caught fire on April 23, 2026, was an underground PVC drainage pipe, the same kind of plastic that caught fire in August 2024. After that 2024 incident, the county stated on the record that they would replace the plastic drainage materials in this corridor with metal. 20 months later, the plastic was still there, and the bluff did what it always does. At 10:26 in the morning on April 23rd, Santa Barbara County Fire received a report of smoke at the cliffs. By Thursday afternoon, the flames are extinguished. The smoke is visible from the UC Santa Barbara campus that morning, captured by the Alert California camera system operated by UC San Diego. No structures threatened, no evacuations. The deeper event started millions of years before the call came in. The Hope Ranch coastal corridor is compressed sedimentary rock, uplifted by the collision of tectonic plates over geologic time. Whatever is happening here is not seismic. It's not magmatic. And it's unusually well documented because Jim Boles, professor emeritus of geology at UC Santa Barbara, has spent decades on it. Boles measured the heat the bluff generates. Inside the rock, temperatures reach as high as 450 degrees Fahrenheit, generated entirely by oxidation with no flame, no friction, no volcanic source. That's hotter than a residential oven on its highest setting, in a cliff face with nothing burning yet. The recurrence list goes back to 1795. A sister vent at Rincon was discovered in 1835. In 2006, a sustained shale fire on this same corridor took weeks of continuous water flow to extinguish. Named flare-ups followed in 2017, 2019, 2020. July 2021, August 2024, and now April 2026. Roughly one ignition every 2 to 3 years. Here's the strange part. The same chemistry happens on the surface of the Earth all the time. Pyrite oxidizes. Marcasite oxidizes. The minerals release heat as they react with oxygen. It happens in mine tailings, in road cuts, and disturbed soil. Millions of times every day. None of it catches fire. So the question Hope Ranch opens is, what's different here? The answer comes from Boles' published research summarized in a 2021 Santa Barbara independent interview titled Geology 101 with Professor Jim Boles, No Volcanoes Here. The single most important sentence Boles delivered was this: if the heat is contained, temperatures will build and things will catch on fire. Boles compared it to a compost pile. Things get hot inside a compost pile because the heat has nowhere to go. The Hope Ranch bluff is essentially a compost pile with fuel inside it. Each time the cliff face slides, which it does constantly, fresh fissures open into the rock. Those fissures run through layers that contain iron sulfide and the same offshore tar that produces the natural gas seeps in the Santa Barbara Channel. The reaction happens inside a confined space surrounded by hydrocarbon fuel with limited but continuous airflow. Temperatures rise, the tar combusts. Boles also corrects the local nickname. The site isn't a solfatara. A true solfatara is a volcanic vent driven by deep geothermal heat. The Hope Ranch Bluff has none of that geological architecture. What it actually is, more accurately, is a chemical reactor, open to the air, with fuel inside. So the second question that opens here is what to do about the part of the system humans built. The recurrence interval is roughly 2 years. The temperatures inside the cliff face routinely exceed the ignition point of petroleum-based plastic. The unresolved part isn't what's happening inside the bluff. is what's being placed near the openings the bluff produces. In August 2024, the bluff flared up and ignited a plastic drainage pipe in this same corridor. Crews extinguished it within hours. County fire officials then stated, publicly, that they would replace the plastic with metal. The reasoning was straightforward. Petroleum-based components can ignite under the heat the bluff produces. 20 months later, the April 23rd fire ignites the same material. Karen Cruz-Orduña, Santa Barbara County Fire Department spokesperson, describes the April 23rd ignition. It isn't a true volcano, but a natural solfatara, a vent in the coastal bluffs that releases heat, steam, and sulfurous gases due to underlying rock formations. That vent periodically flares up and can ignite vegetation or nearby materials. The department's statement on the day was more specific. Today, the activity has caused a smoldering fire in an underground PVC drainage pipe, producing visible drift smoke in the immediate area. What that means is the cost the public absorbed on April 23rd was the response. Fire crews dispatched, a corridor closed, residents told to stay away, to a failure mode the county had already named and committed to engineering out. There's also a quieter disagreement running through the official sources. Battalion Chief Adam Estabrook of Santa Barbara County Fire has previously described the trigger mechanism as friction within shale generating heat. Boles explicitly contradicted that framing. Friction has absolutely nothing to do with it. The University Geology Department has been clear for over a decade that the friction theory is wrong. The gap matters for one specific reason. If the mechanism in your operational manual is friction, you wait for an unusual event to start a fire. If the mechanism is oxidation in the presence of fuel and containment, you know the fire is coming on a cycle, and you build accordingly. The other striking thing about Hope Ranch is that the first detailed description of it, catching fire, was written in 1795 in a letter from the Spanish governor of California. Pedro Fages, governor of Spanish-controlled California, wrote a letter describing the area. His exact words translated, "Throughout this site, the ground is so hot one cannot approach it. It burns continuously in more than 30 places, like geysers that exude dense smoke. From its stench, it appears to be from sulfur." Fages wasn't describing a one-time event. He was describing a steady-state condition. The bluff was already smoking. The chemistry was already running. The only difference between his observation and the April 23rd fire is that there were no plastic drainage pipes in 1795 for the heat to find. There's a sister vent on the same coast. In 1835, a similar feature was discovered along the Santa Barbara County shoreline at Rincon. By the 1880s, the Rincon vent was sending flames 10 feet high and flinging rocks into the air. Then it went dormant. It has been quiet for nearly 140 years. So Hope Ranch isn't an anomaly on a stable coast. It's the active expression of a chemical process that produced visible flames here before the United States annexed California. And there's no known shutoff mechanism. The Rincon vent went quiet on its own schedule. Nobody made it stop. Nobody knows how to make it stop. The fire department's response time on April 23rd was less than an hour. The county's stated intention to replace the plastic with metal was made in August 2024. The pipe that ignited 20 months later was plastic. There's a particular kind of slow infrastructure decision that a known chemical hazard produces. One where the science is settled, the recurrence interval is short. The mitigation is engineering grade obvious, and the failure mode keeps showing up on schedule because nothing has actually been replaced. The bluff isn't waking up. It never went to sleep. It just lit a different pipe this time. If this story is worth telling, subscribe. We cover more of these every week.